Okay, so what do I like about the unit circle? Well, first of all, you have to understand what unit circle means. It means radius is 1, right? So what's cool about this circle is that formula we had the other day, S equals R theta, is now S equals 1 theta. In other words, S is theta. So what's really neat about this is if you decide you want to travel, let's say 2 inches along, let's say that this is a 1-inch radius circle. If you travel 2 inches along here, what's cool about the unit circle is that is not only your S, that's not only how far you traveled on the edge, it is also your theta. So your central angle is 2 radians. Beautiful. That's nice and consistent. And then it gets really cool when you actually look at the coordinates of this point. The coordinates of this point are cos 2 sine 2. Make sure your calculator's in radians. Make sure your calculator's in radian mode when you type that. So I'm just curious, like, where that is. So I'm going to type that into my calculator real quick. Definitely want your calculator in radian mode, okay? Because we just used the formula that requires it. Cos 2 sine 2. So the coordinates of that point are officially, point P is at negative 0.4161, comma, 0.9093. Those are the approximate coordinates at that point. So this is what I love about the unit circle. The distance you traveled, the angle you traveled are the same, and to get the coordinates, you only need that number of distance you traveled. Either the red or the blue, they're the same. Just do cos 2 sine 2, and you've got your exact position on the grid. Beautiful system. Okay? You can see why mathematicians like this. It's elegant and simple. You might say, well, I'd like to know how many degrees that is. Well, 2 radians is close to 120 degrees. Look at everything down to even the signs are correct. Look at the coordinates at point P. Negative for the x and positive for the y. That's quadrant 2. That's perfect. Everything's perfect. So it's just a great system. So mathematicians gravitate toward it. Okay, the only annoying thing is pi keeps rearing its ugly head. And maybe we should think of pi as beautiful. Okay? So pi raises its gorgeous head every now and then. For example, if we didn't travel by 2, but rather traveled by pi over 2, or something like that, that would make things actually a little tidier. So what happens is when you start traveling distances related to pi, like pi or 2 pi or half pi or 1/6 of pi, things start to get real tidy, and you don't get always these messy answers. Sometimes you do, and often, but you can get some nice clean answers. If you travel a whole number of units in blue there, you're going to get a funky answer for coordinates. Okay? All right, so we were just doing this with special angles. Like we were talking about, suppose you went 30 degrees, or suppose you did 45 degrees, and we mapped out several of those. So the ones we've mapped out so far are, we've done 30 degrees. We talked about the coordinates at this point. We've done 45 degrees in the first video, right? And then 60 degrees. We got those. We kind of skipped over 90. We went to 120 and 135 and 150. And then you were supposed to do 210, 225, and 240 for me, but I'm sure maybe you kind of forgot. And then also 300, 315, and 330. So if you haven't yet done those, I would like you to have the coordinates for those points. You already have the coordinates for these top 6 in your notes. So now you just need to go and find the coordinates of the bottom 6 in your notes. Okay, and try to put the sine, cosine, tangent, and the 3 reciprocal functions as well. But that's your job. I'm not going to do that for you. What I'm going to do now is go on and talk about those ones we skipped. We did not look at 90, we did not look at 180 or 270 or 0. Okay? All right, so let's do that now. So these guys are called the quadrantal angles. So what about 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, those kinds of things. First of all, these are called quadrantal angles. And they are here, this is 0 degrees, right? This is 90. This is 180 over here. And this is 270 down here. So they aren't actually in a quadrant. And yet they're called quadrantal. They're actually the borders between the quadrants, but they're called the quadrantal angles because they form the 4 quadrants. All right, so let's go ahead and continue our table. If you did not do the 210 through 330 yet, you need to leave some space. Or just make this an entirely separate table. So we have theta, remember? And we have drawing. And we have sine, cosine, and tan. And then we have the 3 reciprocal functions, cosecant, secant, cotangent. All right, so let's get going on this. So the first one I'm going to do is actually 0 degrees. And if you multiply that by pi over 180 to put it in radians, that's also just 0 radians. 0 pi radians, or I'll just put 0 radians. The drawing for it is kind of trivial. Just basically got your circle here. You're right here on the far right at the point 1, 0. So this is the first time where we've actually known the coordinates before we knew the trig ratios. You know, I mean, we kind of did a little differently with the triangles. We kind of drew the triangles and we figured out the coordinates, and from there the trig ratios, I guess. But yeah, here we're actually just jumping straight to the coordinates because this is the unit circle. We know exactly where that point is. And we've already established that cosine is x, right? Cosine is x on the unit circle. And sine is y. So we've already got sine and cosine figured out. There's no triangle to draw. It's kind of a special case, isn't it? Okay, so cosine is 1, sine is 0. For tangent, do you guys remember how we calculate tangent? It's supposed to be y over x, or you can do sine over cosine. Doesn't matter. Same thing. So what do you get? What do you end up getting? Not 0. Oh yeah, 0. I'm sorry. Last period I did 90 degrees first. Yeah, so it's 0. 0 over 1 is 0. Good. Okay, now let's go and write our 3 reciprocals. What's the reciprocal of 0? No such thing, right? Okay, what's the reciprocal of 1? 1 over 1, right? And the reciprocal of 0. So we get undefined, 1, and undefined. So if somebody asks you, what is the cosine of 0? You're supposed to just reply 1. You're not supposed to need a calculator for that, see? If they ask you what is secant of 0, you say 1. If they say what is cotangent of 0, you say there is none. It's undefined. Okay, so let's go on. Let's look at our next quadrantal angle. That would be 90 degrees, the top of the circle. If you multiply that by pi over 180, you find that it's pi over 2 radians. So we're at the top of the circle, and the top of the circle has coordinates 0, 1 this time. Right? So for your x, you have 0, and your y, you have 1. So sine is 1, and cosine is 0 this time. Tangent is actually undefined, because we can't do 1 over 0. And the 3 reciprocals are, what's the reciprocal of 1? 1. What's the reciprocal of 0? Undefined. And although undefined is not a number, we can think of how we got it. Remember how we got the 1? It was 1 over 0. Well, if we reciprocate that, that's 0 over 1. So that comes out to 0. So we probably shouldn't say this, but it's kind of like the reciprocal of undefined is 0. All right, let's go on. The next one would be the left side of the circle. How many degrees is that? 180, right? Also known as pi radians. So we're on the far left of the circle. The coordinates are, class, what are the coordinates at this point? -1, 0. So your sine is 0. Your cosine is -1. Your tangent is actually 0. And the reciprocals are undefined. -1, undefined. We have one more of these, and then we'll call it a day. Your homework tonight is on the board. Okay? It's at 395. The last one is at the bottom of the circle. When you're at the bottom of this circle, what are your coordinates? Oh, actually, let's start with this. What is your angle? 270, right? So this is the 270 mark. If you multiply 270 times pi over 180, this actually reduces to 3/2. So this is the 3 pi over 2, it's called. 3 pi over 2, let me just write that. We're at the bottom of the circle. The coordinates are what, class? 0, -1. So sine is -1, and cosine is 0. Tangent is undefined, and the three reciprocals are -1, undefined. And x over y is going to give us 0 for cotangent. Okay, so you guys might have taken Ms. Chen's class.